Okay.
మొత్తం 61 కనిపించాలి. ఇక్కడ కనిపించాలి.
హలో మేడం.
జాయిన్ అయ్యారు కదా సార్?
జాయిన్ అయ్యాను. వినబడుతుందా?
వినిపిస్తుంది సార్. స్టార్ట్ చేద్దాం సార్. సార్ శ్రీనివాస్ సార్. సార్ శ్రీనివాస్ సార్. సార్ శ్రీనివాస్ సార్. ఇంట్లో ఉన్నారు. Respected Honorable Vice Chancellor Professor Sita Ramarao garu, Director Academic Professor Sudha Rani garu, Registrar Dr. A.V.N. Reddy garu, Dean Faculty of Sciences Professor Pushpa Chakrapani garu, and all the faculty members, counselors, and dear students, a very good morning to one and all. Today, the Department of Mathematics is organizing its second webinar through online. Today, the topic is on visualization tools in mathematics. I extend a warm welcome to all the attendees in this webinar. Now, I welcome Professor Pushpa Chakrapani garu, Dean Faculty of Sciences, who is Director of today's program. I also welcome you, Madam. Since Madam is having another meeting, she is unable to join with us in this webinar. So now, I welcome speaker of today's program, Dr. C. Govardhan garu, retired Associate Professor, Department of Mathematics, Osmania University. Welcome you, sir. Thank you for accepting our invitation, sir.
Thank you, madam.
Now I welcome Senior Most Professor from the Department of Mathematics, Dr. B.R. Ambedkar Open University, Professor Kupsamarao, sir. I welcome you, sir. Heartily welcome you, sir. I am very happy to see you in this webinar, sir.
Namaskaram, sir.
Namaskaram.
I welcome Dr. Professor Srinivas garu, Head Department of Mathematics, Dr. B.R. AOU. Welcome you, sir. Sir, Srinivas, sir. I request you, Professor Srinivas garu, to speak about the webinar few words. Okay, sir may join very soon. Now I would like to introduce speaker of today's program. It is a great pleasure for me to introduce our speaker today. Dr. Govardhan garu did his MSc PhD in mathematics. He has 32 years of teaching experience and 10 years of research experience. Dr. Govardhan garu worked as a chairman, Board of Studies in Mathematics at Satavahana University. He also worked as coordinator, Computer Science, Department of Mathematics, Osmania University. Dr. Govardhan garu served as Program Officer, NSS KSM, Osmania University Unit at Kottagudem. He also served as Additional Chief Superintendent of Examinations at Kottagudem School of Mines, Osmania University, Kottagudem, and also served as Warden for 3 years at PG Hostel for Boys, Osmania University, PG College, Nalgonda. Dr. Govardhan garu also worked as Program Officer, NSS, Osmania University, PG College, Nalgonda, and also worked as Principal, Osmania University, PG College, Nalgonda. And he also served as Additional Controller of Examinations, Osmania University, Hyderabad. Dr. Govardhan garu published research articles and published many books, nearly 20 books. He organized many national seminars and conferences. Dr. Govardhan garu was awarded Professor N.V. Subbarao Memorial Gold Medal by Osmania University for securing highest marks in MSc in the entire Faculty of Science. He was also awarded HAL Gold Medal by Usmania University for securing first position in PG degree in mathematics. And he was also awarded Indian Mathematical Society Gold Medal by Usmania University for standing first in mathematics. Now I request Dr. Govardhan Garu to give lecture on visualization tools in mathematics.
First of all, thank you, madam, for your nice presentation. Can you hear me, please?
Yes,
Am I audible?
Audible, sir.
The audience. First of all, my namaskarams to my teacher, Professor K. Kupsam Rao garu. Namaskaram, sir.
Thank you. Thank you. It's a pleasure to be here in the audience.
When I am given this opportunity to speak to the students belonging to UG and PG, and I have chosen this topic. This is one of my favorite topics. And when I get back myself to 30 years ago, when I was there in BSc classes, or 35 years ago, most of the concepts used to be quite abstract to me, particularly when I'm studying that abstract algebra or real analysis. Those epsilon delta businesses in finding limits, they used to boggle me in those days. But having gone through so many years, now that with the advent of computer science and we can visualize, for that matter, any concept. And not only in mathematics, you take physics, chemistry, anything. We can visualize almost all the concepts that are taught in the classroom. So, but then if I confine myself only to the blackboard teaching, with chalk piece, I may not be in a position to explain them so efficiently. For example, if I want to draw a sphere, I may hardly end up with a circle. That may look very awkward if I'm not that artistic in drawing the figures. So the layout that sphere, if I allow two surfaces to collide, how about the resulting curve? How about the picture for those things? I think in the usual traditional classroom, I think making them visual is quite difficult, right? But then there are several tools even to visualize such solids and surfaces, curves, regions, whatnot. And moreover, you can visualize the concepts like limits, continuity, uniform continuity. All those things you can visualize nowadays with almost no effort. One need not have any special knowledge in using those tools to bring them to the classroom teaching. So my present lecture revolves about introducing these kinds of tools which can be integrated while teaching in the classroom. So most of the tools that I'm going to use, they are in fact free for download, and you can download them for free. You need not pay anything. They're not commercial. So let me try to look into a few topics in this particular direction. First, let me begin with some grapher tools. And then I would like to look into some of the course assistants. That means while learning some courses, they make your problems so easy to solve them. Some course assistants like that I would like to show you. And let me confine only to the graduation level mathematics. And then let me try to go to some beautiful, important websites wherein some content belonging to linear algebra, real analysis kind of things are put into those websites wherein you can learn that particular content interactively. So many animated figures will be there. So many quizzes will be there. You can put your questions, you can get your problems solved. You can see some simple Java applets also wherein you can visualize the concepts. And let me show you some interactive courses and some course assistants and some grapher tools. So these are the three kinds of things I would like to introduce to you, and most of them are free. Or else you may have to pay very minimum amount, one-time payment. For the course assistants, you may have to pay a little bit amount. That is only one-time amount, which costs not more than watching a movie in a cinema theater. I think that will not be a burden on anybody. So without wasting much time, let me just, because the time is too short for me, I have to confine to 1 hour. So just let me go through those things. So let me share my screen. I would like to share my screen. The screen is visible to you, please? Is the screen visible to you? Hello? Hello? Am I audible, please?
Sir, you are audible, sir.
Yeah. Screen is visible to you? Screen?
Yes, sir. Yes, sir.
Yeah. All right. Yeah, first, let me start with grapher tools, particularly. And most of the participants might be aware of these tools. First, I want to show you this. This tool is called Geogebra, and most of the participants might be aware of this because nowadays schools are using this app. Geogebra. So the name is nothing but hybrid name taken from geometry's first few letters and algebra's last few letters, Geogebra. So one can download this particular app freely from the internet, geogebra.org. The point is that this particular app is going to make a thoroughfare between algebra and geometry. You draw a figure on the plane given, and then you can see its algebraic part on the left side, right? And when you draw something, when you type something on the left side, its geometrical configuration can be seen there on the right side. For example, if I type y is equal to x square, you have the parabola with you, right? You have the parabola with you. You have the parabola with you. So even if I write something like say y greater than or equal to say x square, sorry, I have to type properly. So if I put instead of equality, you put just less than or equal to, you can get this region. So regions and curves can be drawn pretty easily by using this app. I have written geometry there, or algebra there. I have typed some algebraic inequality there. Its geometrical configuration can be seen. And most of the times, geometry is something which can be seen. Algebra is something which can only be felt. It's there in the abstract. Algebra is something abstract, while geometry is something can be seen, something can be felt, right? When the clear-cut link is established between algebra and geometry, I think people may get thrilled because every algebraic equation will have something to do with a physical object. So this physical typical object can be visualized by means of some simple inequality y less than or equal to x, right? So there are several other tools here. For example, if I look at this icon, you can draw ellipse, hyperbola, parabola, and conic through 5 points. We teach there in the classroom, any equation in 2 variables of degree 2 usually represents a conic section, of course, with some restrictions on the coefficients. And for that matter, through any 5 non-collinear points, one can draw a conic. So that is, I think, visible here. If I choose this conic, trace out a few 5 points, A, B, C, D. You need not give any name. So it itself takes the name. So if I put this one, so that is what we are. This conic hyperbola, right? So everything is spoken there. In the first place, I have drawn, typed some algebraic inequality. Its geometry has been seen there as a region, and I have just taken 5 points in the plane. A corresponding hyperbola has been seen. Right? If I hide this one, now you can see the hyperbola, right? So therefore, this is going to give you a thoroughfare between geometry and algebra. If this such kind of a thing is shown in the classroom to the students while teaching geometry and algebra, I think students may feel thrilled. For this, nothing is required. Just you download the app into your cell phone maybe Android phone, maybe Apple phone, doesn't matter. iOS or Android doesn't matter. Even if you take Windows phone also, such app is there for free download. Just make use of it. Icons will tell you everything. So if I look at this icon, what does it indicate? So there are so many other icons are there. First one gives you the circle passing through a point and with center given. You just take any point here. You having selected this, you take any point here and take another point through which it should pass. This F is going to be the center, and take another point through that point, passing through that particular point, you have a circle there. So this is what you get. But drawing the same thing in the classroom, I think looks, unless I have got that many nautic skills, drawing a circle is not that easy in the blackboard, isn't it? So my intention is that let's try to make use such applications, very small applications, which help us a lot. In fact, they strengthen the hands of the teacher. You can see the equation of the circle is also displayed on the left side. X minus 1.02 whole square plus y plus 6.23 whole square is equal to 8.55. So this is a typical tool which can be downloaded from the internet for free usage to explain the perfect link between geometry and algebra, at least confined to the plane geometry. But there is, in fact, its counterpart in 3D also. That is quite a beautiful one. Let me just go to that. Having seen this, let me show you the 3D calculator. Same GeoGebra's 3D version is this. Now that X, Y, Z axes are there, red, green, and blue, 3 axes are given in the space. Now you can just look at the tools here. These tools are going to give you the configurations that you can draw using this particular app. So if I look at this sphere with the center given, you choose any center and allow that sphere pass through some other point. You have a unique sphere. So let me just take one point here and take another point there. You have this particular sphere with you, right? The moment you draw 2 points, you have this. Suppose if you're not happy with the color, I would like to change the color, green color. Okay, so this is the sphere that I have with me. I can even allow this particular sphere to move. Let's see. So this kind of visualization we cannot make in the classroom if we confine to our traditional way of teaching the things, right? Center is visible to you and a point on it through which this sphere is drawn, and you can see from various cross sections. And you just look into this. All the axes are there. So when I rotate something like this, you can see the full length picture of this particular sphere. So whereas if I want to draw something in the classroom with a blackboard and chalk piece, I think that will not be so good. We cannot at least attract the students nowadays, because the students belong to smartphone era and we belong to blackboard and chalk piece alone. I think that may not attract that easily students. So let's try to make this one. There's one thing, no? And there's another icon to using which you can draw a cube. I chosen cube. Just fix up 2 points correspondingly with that length as the side. It's going to create a cube. Let us take just 2 points. You have the cube. It has chosen its own color, different from this. There is another icon playing through 3 points here. The screen is visible to you, please tell me. Hello? Am I audible to you? Hello?
Yes, sir, you are audible, sir.
So the screen is clearly visible. Icons are visible to you?
Sir. Clearly visible, sir.
Okay, they plane through 3 points. Let's just look at. Trace out 3 points. 1, 2, another point. You have a plane. Suppose if I were to visualize these 3, a sphere, a cube, and a plane. Just try to make. Let's move this total figure. Now you can see. Now you can just. You can see the figure now. Look at here. All that cube along with this plane is intersecting that sphere in a circle. We teach in the classroom plane section of a sphere is a circle. Now that you can visualize that circle pretty easily, right? So such kind of visualizations you cannot make that easily in the classroom by using just blackboard and chalk piece. Am I right? So let's try to make this. There are so many other icons you can just make use, and you can make fun of these things. Even if you introduce them to the students, they make a lot of interesting things out of this. If you look into this geogebra.org website, there are so many other resources which are created by teachers and students across the globe. And you can even download those simple applets in your classroom teaching. You need not create anything on your own. So this is okay, right? You try to explore all the icons that are available in this particular app. It is particularly meant for teachers to use those things and to integrate this particular app in the classroom teaching. So having done this, there is another important grapher tool. I want to explain that. That is, in fact, Desmos. Its name is Desmos. Is it clear? Desmos. This is another interesting grapher tool, which makes so many things so easy to draw. Right. If I look at this one, drawing regions will be quite easy. Just take this and this. One square. So this is what we get. X less than or equal to y square is nothing but this typical region that you are seeing here. And for example, like in the GeoGebra, I can put some parameter here. Let's put some parameter A. And I can create some slider here. Add slider. With various values of A. How does this look like? So this slider is created immediately. So let me make this app to play this slider. You can see as the values of A range from -10 to 10, the region would be something like that. Can we make this to be visible to the students in the classroom by using Blackboard? It's just impossible. But certainly we can make out the theory behind this one through a lecture. But to make that particular theory visual, it's better to make use this app. If you are not happy with the color, you can change the color also. Right? So this is one advantage with this particular app. You can even draw a number of these things. For example, if y is equal to x cube, let me take this y greater than or equal to x cube. Let me take just third degree. So this third degree curve. Let us take a different color here to make out. The part is nothing but my y greater than or equal to x cube. These regions can be displayed so easily. It takes hardly, if I want to draw that particular y equal to x cube, which will have one turn at somewhere x equal to 0. It's not that is in the classroom to do this. Again, here also you can put some slider. In the first case, I have put slider with a multiplied by a, that y square multiplied by a. But let me add plus a instead of that, plus some other a, let me put. You can see with the same -10 to 10. And so easy in the classroom. If such a thing is displayed on a huge screen in the classroom, this looks entirely different. But in order to display all these things, you need not have any screen there. It's just enough to have a projector and nothing else. You connect your projector to your device, whether that is a mobile phone or a laptop or any tablet, that will suffice. You can connect your projector to your desktop or laptop or tablet or mobile phone, doesn't matter. So these are typical simple to download. You need not pay anything for this. We can freely download this. Suppose if you are not in a position to understand how to use this one, then there is, let's close this. Let us see. So these are some examples which are given here. These are some examples given here. Let us see what are there in that. lines slope intercept form. So if I take this lines slope intercept form, the slope as slope changes from -10 to -10 to 10, and that y-intercept b changes from -10 to 10. How do these lines change? You can just make out this. This is the way these lines are going to change. Okay, this you can see so easily. Okay, this is pretty easy to understand. To make it, let's not worry about that. Let me just try to look into this. I'm just trying to look at this polar rows. This is in fact inequality pertaining to or less than or equal to sine A by B theta. Sine A by B theta. Look at this. Drawing a curve R is equal to sine theta itself is a tough job for that matter, right? So, okay, R equal to theta, you can draw it very easily. R equal to theta is going to be a spiral, and that you can do it very easy. But R equal to sin theta, R equal to cos theta, R equal to tan theta, these are going to be quite tough, right? But here he has given an example, R less than or equal to sin A by B theta. It is indeed an inequality with two parameters in it, A and B, right? So instead you can you allow this one to, I want to take some different color here, right? This is the way it changes. So as R changes from, or A changes from -10 to 10 and B moves from -10 to 10, there's the shape of the graph that comes into picture. So beautiful configurations can be generated by using this particular app. Okay, you can even remove this B. If you want to play only with one parameter, it's okay. So this is with one parameter. B is not there, and A, when A runs from -10 to 10, it's something like a petals of a flower, right? They're looking like a flower. So these are called polar roses. In fact, they look like rose flower. This is what we get, but you cannot make out this one to be so clear in the class. Remember. So this is another very beautiful tool which you can make use in the classroom. Nothing is required. Just download it and try to look into that particular content which is there on this. Open, these are the contents available in this one. Using this, you can make your own presentations. Just imitate that and draw something of your own and show for the same thing to the students in the classroom. We can show them to the students. Right? So this is another tool I wanted to introduce to you, but I have got my own grapher tools in the iPad. I'm showing my lecture through iPad. iPad has got its own inbuilt such grapher tools. They're very, very powerful, of course. My iPad has got its own grapher tool, which is more powerful than this. But having done this, I want to show you something different on course assistants. And suppose in solving some problems in the classroom after teaching the theory behind that. For example, if I'm teaching the differential equations, and if I'm teaching, say, first order or second order ordinary differential equations with constant questions or variable questions, it doesn't matter. You'll have a definite method, and you will explain the same thing with some examples. But if I want to solve the same another example, I may have to forego at least 10 to 15 minutes. If I were to solve 3 or 4 problems, you have to forego total hour, 1 hour. When the method looks quite routine, and with a little bit of practice, and people can do the problems on their own. Of course, they must have some basics in the subject. One doesn't have any basics. Making them to solve them is not that easy. Okay, but certainly with some basis, certainly once you explain the methods behind solutions of those differential equations, solving a differential equation looks quite a routine job. So when a routine job comes into picture, why should we focus so much of time in solving them? You can actually make use some tools which are going to make your job so easy. For example, if I take this, this is called, in fact, these are called typical solvers. In fact, it's like a course assistant only. So these are the subtopics which can be handled by using this solver. So for example, if I want to look at integration by part, Integration by parts looks a bit tough for that matter. So let me take, there are some solid examples here. X to the power 4 log x whole square dx. That's the problem which has been solved thoroughly step by step in these. And the formulas that are used in solving this problem, they're also displayed in the down, in the notes part of it, right? But if you want to show the same problem as if you are doing the same on the green board with white chalk, you can do it. So it's going to solve step by step like this. It will show you all the steps. So to go for the integral of x power 4, you have to make use the formula exponent integral to be exponent plus n plus 1 and it's some constant. Same thing he is using. Integration by parts. So if you are not happy with the speed, you can increase the speed or you can slow down the speed. You can slow down, you can increase, right? So it's going to solve step by step. I need not forget any time. Why should I make use so much of time in solving this? You put the problem there, it will solve. Just explain the steps behind it, right? But then you may be surprised. Suppose if I introduce this particular tool to the students, and I think they may not go for any practice at all. We should not worry about that. We need not worry about that. For example, when I put some questions like this to my MSc students when they come to our university, what happens is if I put some question, they immediately try to solve the problem. But most of the people do not know that that problem can be solved or cannot be solved. Nobody knows whether that can be solved or not. But they start doing the problem. They do not know whether they end up with a solution or not. And what is wrong with the teaching? We are showing them so many problems which can be solved by using techniques available in the textbook. We are not exposing them to those problems which cannot be handled by any of the techniques that we teach in the classroom. That part is ignored. For example, if I put a different problem here, instead of 4, I would like to take some x alone. If I ask my machine to solve this, it will solve immediately. It's not that only problems which are displayed that they can be handled, but now that the problem is solved. A different problem I have taken, it's a different problem altogether. I think within 2 seconds, you have the solution with you. So I think this looks so pretty, compared to our own writing and those things. Right, okay, but then what is the use of this? I say you can make your theory so nice by using this. So instead of solving this integral, I want to put another question here. Instead of x into log x whole square, I want to take divided by and see what's going to happen. I will take this question. I want to ask my machine to solve this. What does it do? The problem sort of failed for the input problem. What is the meaning of this? This is a problem which cannot be handled by using the techniques available in this particular app. Of course, this particular app uses all those techniques which are being taught in the classroom. So classroom techniques that we have exposed, we teach the students, they're not sufficient to answer this question. So that will be displayed here. Then the students may start looking for the solution. Why? It looks all right. What is the problem? Why can't we solve this? That fellow may try to go for the solution of this problem. Of course, every integral, every function which is continuous can be integrated in the sense of Riemann. Of course, this may fail to be continuous at x equal to 0. But of course, for any x positive, it's going to be all right. You take any x positive, it's going to be a continuous function. At least we must have its integral. But in the closed form, we cannot have any integral for this. So we are not exposing such kind of problems to the students in the classroom, right? So if I put the same question to my students in the class, they go on solving this one by using substitution or integration by parts. They try to go through various techniques and they try to solve it, but they never know that it will not have any closed form solution for this problem. So therefore, we can certainly improve the quality of teaching by using such apps in the classroom. So nothing to worry that they are going to use all these apps to answer the questions. No problem. So this is one typical course assistant wherein you can put your own problem. You can ask this particular tool to solve it. It will solve within no time. Okay. I want to show you some other set of course assistants which pertain to graduation. This intermediate level problems you can handle this. Such course assistants are there for algebra and more generally math topics of elementary nature. But I want to show you some other course assistants which can be used. So am I audible to you, please? You can put some questions in between also.
Yes, you are audible, sir.
In between also you can interrupt me and you can put some questions. If possible, I will try to address them. Okay. So let's try to look at this particular advanced calculus. So this is multivariable calculus, and in fact, this is one of the tough courses at graduation level, which is being taught at the graduation. Even it's a common course which is for their engineering students also. It looks a bit tough, particularly when you are going through the multiple integrals and so on. So integration business, there are three types of integrals: single integral, double integral, triple integrals. When you want to look at triple integrals, I think there's a big business for us. Triple integrals means something triple integral f x y z divide dz divide dx or dx divide dz. That's what you have to integrate over some typical surface given between some limits of x, y, and z. So I want to take some. He has given some problem. Some problem is given there. But you can change the problem. Instead of x square cos y plus z, I want to put some z square y. I put z square y. So this becomes entirely a new problem. Let us ask the machine to solve it. So problem is over. Right? This problem has been solved, something like this. But if I were to solve the same problem in the classroom, you have to forego so much of time. You can try to look into the definite integrals also. There is some problem. Let's try to. This is the definite integral, which turns out to be so much, right? You can put so many questions for this. Differentiation, you can ask this: critical points, saddle points, local extrema, gradient, partial derivatives, and so on. Almost all the topics from the calculus can be put to this partial derivatives. And you are giving some function there in x and y. You're asking that machine to solve with respect to x, but I want to ask with respect to y. Let that compute. Yeah. This, I think, dou by dou fx just and y, x square cos it's quite easy. But instead of x square sin y, let me put some xy. This becomes a tough problem. Yeah. Remember, the advantage of this course assistant is that not only it's going to give you the partial derivative of this function with respect to y, you can even have step-by-step solutions also. You can just see these steps also. These are the possible intermediate steps, please. This explains you have to make use chain rule and all those things. Ultimately, answer is something, right? This is what x cube cos xy. But by the by, you can even see the plot of that particular partial derivative also. This is the 3D plot of that particular. This is the 3D plot that you are showing. And you can even see the contour lines also, which make out this particular surface. But these things you cannot, we may not be in a position to teach in the classroom, regular classroom. Suppose having got this to be the partial derivative, can you draw this one in the classroom? Just impossible. So such a typical configuration or such a typical geometrical object is the resultant of this partial derivative. It is something like f of xy. This something like f is equal to x cube cos xy. Its graph is this. Its contour plot is going to look like this, right? So these are the advantages. So many other related stuff can also be seen here, right? Even for that partial derivative, you can look for integral also. That integral is given here. So therefore, so many things can be learned and can be taught by using these kind of course assistants, right? You put any, for that matter, just take any function. You can look for its critical points also. It's the function is x power 4 plus y power 4 minus 16xy. It's you can see the critical points and you can see those, and its graph can also be seen. You can put any question of your choice instead of this. Let's say 16x plus 16y, let me take. There's a new question. No? It will try the answer. So these are the critical points. Only one critical point appears to be there. And whereas if I were to solve the same thing, you have to get two equations, you have to solve them. Sometimes it may not be that easy to solve cubic equations, but it has done the problem straight away. Right? This is something different. There are so many such typical apps that you can make use in the classroom. I have with me the calculus, pre-calculus, advanced calculus, algebra, pre-algebra, linear algebra, discrete mathematics. These are all the areas which are covered in graduation level and sometimes PG level also. You can see these courses. Linear algebra will be there in the PG course. You can see in the linear algebra course assistant, you can see eigenvalues and eigenvectors of a matrix. You can just see the characterization. If you look into this matrices effect, if I just take matrix information, you take any matrix, total information flows pertaining to that. So this is the total information pertaining to the matrix given. 3 minus 1, 7, 5 minus 4, 2, 9, 11. And its plot can also be seen. Remember, there is a one-to-one correspondence between the numbers and the colors corresponding to them. So if I put the colors corresponding to these numbers, this is the matrix plot. Matrix plot is given. A little bit of no, the characteristic problem will become so much. Eigenvalues are these. You can put some other problem also. Instead of 11, let me just take some other question. 1, 2, 3. Say 1, comma 2. Let me close. Comma 3. Close. 2, comma 3, comma 4. And comma. I'm just taking square matrix to have all those things. 4, comma 5, comma 6. Close it. Let's compute. All its features are going to be displayed there. So all the features not displayed. Trace happens to be 10. That's very clear. Determinant happens to be 0. We know that its determinant is 0. Its eigenvalues are so many. All those things are displayed now. You can see in nullity, everything. This characteristic problem can also be obtained by using step-by-step solution. See here, when you look at this particular app, Laplace expansion is one method, row operations is another method. By using row operations also, you can find out this. So this is the method which you can see. So all these things can be had very easily by using these course assistants, which can be made using the classroom. If not in the classroom, you can make out some problems around and take out those pictures, put them into slides, explain them in the classroom thoroughly. So that even saves your time to a greater extent. You can save a lot of time. You can put some problems of your choice into this and get some solution and take them in the clean format and download that, put into some slides and explain them thoroughly using projector. That looks so beautiful rather than using blackboard chalkpiece. Right? Yeah, these are some apps actually. So having done this, I want to show you another very interesting typical thing, namely knowledge computing engine. I want to look into that particular engine. Is this? Its name is Wolfram Alpha. I have been advocating for this particular app to use this particular app among the circles, teaching circles. And most of the teachers are now habituated to use this. What actually is this? Wolfram Alpha. Suppose if you have got some query with you, what would you do? Usually you put that query into any of the search engines and that immediately reacts to your query and lots of information flows into that. And sometimes digging the right answer for your query becomes quite tough also. And besides so many distractions on the screen, when you put some query in the Google search engine and you are immediately followed by so many distractions, first point. And the typical search engine, what does it do is just you put some query which contains some words in it, corresponding each and every word that appears in your collection of words in your sentence. So all of them get reacted pertaining to all those words. So much of information flows into the screen. And digging the right information which is required to you would be a quite tough job. Another point, it's authenticity. That is also a big problem. How to wield that? So I think that there are several problems. Instead, I have got another typical search engine, which I call it a knowledge computing engine. You put any question of your choice from any discipline of science. It may be from mathematics, maybe from chemistry, physics, biology, biochemistry, name any branch of science, political science, history, whatever. And you put any question, any routine question, of course, any routine question that you put, you can get your answers done immediately. For example, if I ask my machine to find out the limit of this particular sin x minus x by x cube, where it tends to 0, that is the answer. Graph also you can see. You can see the graph immediately. What is the graph here? This is the graph, and its solution is -1/6. How is that this machine has seen this answer? That fellow has expanded sin x minus x divided by x cube. He has taken some terms. So this term on x square and everything goes to 0. -1/6 would be the answer. Or else you can make your LH rule to work, and the answer is going to be -1/6. Instead of this, I can put some other question of your choice also. Instead of putting x cube, if I put x power 5, we shall see what's going to happen. Yeah, it's -infinity. So the answer flows so quickly, right? You can even see the methods of solution, that step-by-step method for this. So this is the way the solution is done. You can download this copy and paste into your slides, and you can explain the problem. You need not do so many computations, losing so much of precious time all the time. For 1 or 2 problems, it will be okay in the classroom, but doing so many routine problems in the classroom, foregoing so much of time, I think that is unwanted for us. So not only that, another advantage is for this kind of tools to be used in the classroom is that, for example, if I want to make use sin x series of, let us say, sin x. About, of course, x equal to 0, he has taken that into account. So while teaching in the classroom about Taylor series or Maclaurin series, what we do is sin x is equal to x minus x cubed by 3 factor, x plus 5 by 5 factor, and so on. That we teach by using your Taylor's theorem or Maclaurin's theorem. You can go for expansions of these series about 0 or any other point. How do we make the students that the sin x, which is a transcendental function, the right side is an infinite series containing polynomials of x? How is that these two are related? You may be aware of that Stone-Weierstrass theorem, which says that every continuous function defined on a closed interval can well be approximated as the uniform limit of a sequence of functions, series of functions. Same thing. In other words, a typical transcendental function can well be approximated with a polynomial of greater degrees. That's what we get. So more the number of the terms that you increase on the right side of this sin x, that comes very closer to that sin x. So in other words, I'm approximating sin x with the series x minus x cubed by 3 factorial plus x power 5 by 5 factorial, and so on and so forth. If you go on increasing terms on this series, the graph of that series would be quite closer to the graph of sin x. In other words, we are, in a way, approximating sin x with that kind of series of polynomials. And that can be visualized by means of adding more and more terms. Suppose if I put more number of terms. The red colored picture is a graph of your sin x. If you increase some more terms, the graph comes very closer to that. But these things can be seen so easily by using your graphs. You increase more number of terms here. If you increase more number of terms, correspondingly, I think these blue colored graphs come closer and closer to this red colored graph, which is graph for sin x. But these things can be shown to be so easy in the classroom rather than explaining in words or through your reasoning. But better to show them. Most of the time it says most of the times seeing is believing rather than listening to, right? Most of the times we believe by seeing only. So let's try to make them visual everything that we teach in the classroom. So which I'm just left with only 10 minutes or so. I'm just opening for the comments, please. You just make out your comments and let me try to speak about that. Madam, my screen is visible to you?
It is visible.
Yeah. Yeah. Ask the participant to pose some questions. I want to show them some websites wherein that interactive content is there pertaining to some subjects taught at UG and PG level. For example, linear algebra and so on. Time is a major constraint on me. I cannot show them. But certainly I would like to send those typical things to you. You can pass it on to the students. So this typical search engine, from this search engine, you can put so many questions from so many areas: life sciences, space, engineering, physics, statistics, chemistry, and so on, art and design, music, whatnot. You can put questions from so many things, shopping, whatnot. So you can put questions from so many areas: computational sciences, engineering, space and astronomy, statistics, chemistry, whatnot. You can put so many, for example, if you take physics, mechanics, so you can put these questions. So to compare the mechanical work done with force so much and distance 100 meters, you can get the problems done so easily. This is the step-by-step solution. The relation between force, distance, and work is this. Thereby, you can go through the solution, right? From various disciplines of science, you can put some questions, you can get the answers by using this computing engine. Okay. Questions, please.
So anybody, if you have any queries, please ask, sir. Sir will clarify your doubts. Please.
My point is that learning nowadays is fun. It's not that difficult if you are exposed to all these kinds of tools. For day-to-day activities like paying current bills and shopping, for various other purposes, for getting some things done through Swiggy or Myntra or Facebook, there are even various apps for our daily needs. No? If you, please. For shopping, for grocery, for anything and everything, we are using some apps. My point is that these apps are much simpler than those apps which we are using, like Swiggy, Amazon, Facebook, Instagram. We are using all these kinds of apps for various purposes. And using these apps is quite easier than those. That's my sincere request. So between knowing and not knowing these apps is like hairline difference is there. So nothing to worry. Just download from the internet for free and start making use of them in the classroom. You will come to know that using these things will be quite easier than using your Facebook or Instagram or anything. Those apps most of the time eat away your time. Very few people are putting them into right use, but now these things are going to give you some knowledge, right?
If you don't have any queries, please make the comments.
I would like to make a comment. Am I on? Okay. Govardhan.
Please, sir.
Yeah, you have hit the nail bang on the head, because it's most often many students and teachers of mathematics look at branches of mathematics in watertight compartments. According to them, algebra is different, analysis is different, something is different, something else is different. You have shown now through your lecture that there is a kind of a thread that runs not only through several branches of mathematics, but in fact, all branches of knowledge, all branches of learning. So there is nothing like no person can live in isolation. In fact, as most of the students of mathematics, especially at postgraduate level, consider themselves to be learning higher mathematics. There is nothing like higher mathematics, lower mathematics, lowest mathematics, highest mathematics. Mathematics is mathematics.
Yes.
But then the point here is we take pride in saying that we learn higher mathematics. I quote one proverb. You see an eagle. Eagle always flies in the clouds, but it has to come down for feeding. It cannot live forever in clouds. That's what they say. Anything that flies high can be brought down, for eagle cannot feed in clouds. So we, the students of mathematics, all of us are students of mathematics. We learn, and learn. There is something more to learn. So we must remember that we should always see the connections and then look down upon concrete things as less mathematics and abstract things as higher mathematics. You have demonstrated through this lecture. I am very happy. I learned a lot from your lecture. Thank you.
Thank you so much. Thank you so much. The mathematics is nothing but is something like a storytelling. Storytelling starts at class 1. It goes on in phase manner. So nothing like there is no connection. It's a continuous story. It must be read something in that manner only. It's like a storytelling. We are pursuing MS Math means it's a continuation of BS Maths only. There are some gaps which cannot be handled by using BSc Maths. They will be taught in the MSc level. This kind of bridging is not being done in the classroom. That has to be done actually. Please.
Hello.
Please, sir.
Gordon, sir. Good afternoon.
Good afternoon, sir. Please.
Yeah, I'm Dr. Sharad Babu, your student.
Okay, please tell me.
There is no question, sir. Wonderful lecture on infinite series, convergent series you are explained. We really have a wonderful lecture. Like a expertised person, we learned what is the convergent analysis and what is the upper bound for convergent analysis you are explained. Very nice. Sir. The doubt is order of convergence you are explained, sir. How to identify the upper bound for convergence?
Yeah. Convergence of what? Convergence of?
Convergence, you are telling order of h power k. How to identify that k value? Yeah. This is the accurate k value. We have to restrict here. How to identify that?
Remember, in the same thing, in the same Wolfram Alpha search engine, you put your numerical analysis kind of things. You put your queries pertaining to transcendental equations or algebraic equations or differential equations, integration, differentiation, anything, partial differential equations. Put some queries there into that. Numerical analysis wing will be there. There you ask that machine to solve that problem. Immediately, solution flows. Its convergence will also be spoken there. Even its graph can be seen. Such things can be seen in the same Wolfram Alpha. So there, in the applied math section in mathematics, there will be numerical analysis. In that numerical, let me show you for that. I can show you also, no problem.
Yes,
so
yes,
take Wolfram Alpha, take numerical analysis wing, put some question. For example, if you want look into solve some equations, say find the roots of x equal to cos x, something of that sort.
Yeah, transcendent.
Those roots. You can see the thing there. You mention a method, secant method, that method, any method. Immediately solution flows and its geometrical visualizations can also be had. Its convergence, all those things will be seen.
Which software, sir? Yeah, this one?
Wolfram Alpha. No, Wolfram Alpha.
Okay.
It's a kind of an application, a big application. And it has got various versions. In fact, in the laptop version, it has got a rich functionalities compared to these vision iPads and all those things. Notebook. So you try to access that Wolfram Alpha, wherein you can have this. Other than that, there are some specialized numerical analysis apps wherein you can put any query corresponding to numerical analysis and pertaining to these equations, systems, integration, differentiation, equations, anything. You put some questions. immediately all total particularly you can see numerical recipes.
Yeah.
Numerical recipes is a book which has got lots of functionalities in that. It has got a web version when you can put some and you can have something there.
Sir, good
Numerical-
afternoon, sir. Sir, good afternoon, sir.
Good afternoon, please.
This is Dr. Nagaya, sir.
Please.
Sir, very interesting topic, sir. Today you are given technical tools in mathematics. Sir, I have one question. In abstract algebra, is there any tool for, can you find given set of numbers from a field or a ring or group theory, sir?
Yeah, I would like to tell you one app. So, given any set of elements and
Yes,
some option to check whether that is a group or not,
Yes,
I
sir.
think there are some bigger softwares wherein you can put some questions like this, like Mathematica, Maple. These kind of softwares can be used, but straight away putting that thing, whether that is a group or not, may not be possible. But sir, there are some. You can put such queries in Mathematica software. There you can learn almost all branches of mathematics, please. So there, if you put, in the place of set, you put those elements. In the place of operation, you put something. Immediately,
Yes, sir.
that
Binary operation.
operation fails. Therefore, it's not a go. It will show certainly.
Sir. In the same way, sequence is convergent, divergent, given sequence is also there the software.
Yes, certainly you can do. Even if mathematical very big software or commercial software. But there is another important software called Sage.
Sage
is another software. Octave is another software.
Sir.
What you have to do is just download that and look into the manual.
Sir.
And you look into the branch to which your particular question belongs to. And you read out those pages, how to program your problem into that software, how to get this done. So there you can say everything. Right?
Sir, one more question, sir. మేము యాక్చువల్గా డిగ్రీ కాలేజ్ లో ఉన్నాం కాబట్టి ఇది అడుగుతా ఉన్నాం సార్, మీరు ఏమనుకోదు సార్. ఏంటంటే నవడేస్ మ్యాథమెటిక్స్ కు ప్రాక్టికల్స్ తీసేస్తారు డిగ్రీ కాలేజ్ లో. ఇంత మంచి అడ్వాంటేజ్ ఉన్న మ్యాథమెటిక్స్ కు ఇట్లాంటి ప్రోగ్రామ్ ద్వారా మనం మ్యాథమెటిక్స్ టూల్స్ ఇంట్రడ్యూస్ చేసి అది ప్రాక్టికల్ కు పెడితే ఇంకా బాగా ఉండేది కదా సార్. ఇప్పుడు మ్యాథమెటిక్స్ ని సైడ్ చేస్తారు సార్. మేము హానెస్ట్లీ సేయింగ్ డిపార్ట్మెంట్ ఆఫ్ మ్యాథమెటిక్స్ ఫ్రమ్ కాకతీయ యూనివర్సిటీ, ఇప్పుడు మ్యాథమెటిక్స్ అంటే లైట్ గా చూస్తున్నారు, స్టాట్స్ కూడా ప్రాక్టికల్స్ ఉన్నాయి. ఇంత మంచి అడ్వాంటేజ్ ఉన్నటువంటి ఇట్లాంటి టెక్నిక్స్ ఉపయోగించుకొని మనం ఎందుకు లాబొరేటరీస్ డెవలప్ చేయకూడదు సార్?
డెవలప్ చేయాలి. ఇప్పుడు ఆర్డర్ ఆఫ్ ది డే అది చేయకపోతే మనం బ్రతకం. ఫర్ ఎగ్జాంపుల్, mathematics is there, along with allow them to learn the language Python. Python language పిల్లలకి చెప్పించవచ్చు. ఆ Python లో total mathematics that is being taught in graduation can be taught.
Yes, sir.
We can make the children to do the problems which are there in the textbook by using Python language.
Yes, sir.
So doing maths with Python అనే ఒక బుక్ తీసుకుంటే మ్యాథ్స్ లో ఉన్న కంటెంట్ ని Python ద్వారా ఎట్లా సాల్వ్ చేయొచ్చు అది కనపడుతుంది మీకు అక్కడ. అంటే మనం ఇట్లాంటి చేయట్లేదు కదా, మనం ట్రెడిషనల్ వెళ్తున్నాం. ట్రెడిషనల్ వెళ్తే ఎవరు లైక్ చేసేది? సంథింగ్ రొటీన్ నోబడీ లైక్స్. యు హావ్ టు మూవ్ విత్ ది టెక్నాలజీ కదా. చీఫ్ మినిస్టర్స్ లాంటి వాళ్ళు గూగుల్ అర్త్ ని హైయెస్ట్ వాటిని వాడుకుంటూ మొత్తం రియల్ లైఫ్ లో అన్ని చూస్తున్నారు వాళ్ళు. కాళేశ్వరం లాంటి ప్రాజెక్ట్ 3 నెలలు అయిపోయిందంటే ఉత్తగైంది అది. దే ఆర్ వాచింగ్ ఆన్ రియల్ టైం. అంటే ఒక సీఎం లెవెల్ ఉన్న వ్యక్తి అనే సాఫ్ట్వేర్స్ అంతా అడ్వాన్స్ వాడుతున్నారు. మ్యాథ్స్ వాళ్ళు ఎంత వాడాలి?
మనం ప్రాక్టికల్స్ ప్లేస్ లో ప్రాబ్లమ్ సాల్వింగ్ డైరెక్ట్ మెథడ్ ప్రాబ్లమ్ ఇస్తే చేయకుండా ఇట్లాంటి టెక్నికల్స్ వాడి సాల్వ్ చేసే విధంగా పిల్లల్ని అట్రాక్ట్ చేస్తే బాగుంటుంది సార్. కొంచెం
you have to integrate this particular technology in the classroom. One aspect, you have to make the children to learn languages like Python or Java, these kind of programs. Python is pretty easy to learn. They can straight away begin. We have to make them to learn such languages and make them to solve the problems using Python. So that may form as a practical part of it. That's not being done. Actually, we have to do that. It's not being done.
Gordon, sir, a small request, sir. Small request from my side.
Okay.
In board of studies, you recommend some mathematical labs, sir, for board of studies, at least 1 or 2 labs for engineering students. At least, if time permits for you, if you are one of the member of the board of studies, please, the computational mathematics or Python or Mathematica, MATLAB, you are suggested at least 1 lab.
But particularly, presently, I'm not authorized to do those things. I'm out of the service now. But certainly,
Okay. Suggest your juniors, at least those who are in BOS of studies also. So then the mathematical fraternity will be likely to introduce what is that laboratory skills, lab skills, programming skills, etc.
Sorry.
With that. Programming రావాలి mathematics వాళ్ళకి.
Exactly.
Important. Okay.
Thank you, sir.
Right.
Anybody? Thank you very much, sir,
Yeah,
for
thank you.
giving excellent lecture on visualization tools in mathematics. I hope this lecture will be useful to everyone, which is on visualization tools in mathematics, sir. So I am very much thankful to you for, first of all, for accepting our invitation, as well as for spending your valuable time for us to join, to participate in this webinar, sir. So thank you once again. Thank you very much, sir.
Thank you so much making me to interact with my fellow colleagues and mathematics community. Thank you so much. Wish you all the best.
Now
Thank you, sir.
May you know?
Now I must thankful to our Dean, Professor Pushpa Chakrapani Garu, Dean Faculty of Sciences, who is director of today's webinar. So I am very much thankful to Madam for encouraging to conduct such type of webinars. Thank you, Madam. I must thankful to our Professor Kupswami Rao sir, who participated in this webinar physically. I'm very thankful to you, sir. So I'm very happy to see you in this webinar physically, sir. I'm also thankful to each and everyone for participating in this webinar and make it success. Thank you very much. Thank you once again.
Thank you, madam.
Thank you, madam.
Madam, shall we fill any feedback link?
Yeah. No, feedback link is not available. No need.
Okay, madam.
May you know?
Myself, sir.
Yeah.
Myself, Dr. K. Sharad Babu, sir. I was worked at MLR team. You are ratified me as the associate professor.
Oh, very.
Dr. K. Sharad Babu, presently at Matrasri, sir.
Nice. Okay.
Thank you, sir.
May you know?
Yes, sir.